just one more thing on these body forces, which I've tried to describe how they are acting on the center of mass of your little bit of fluid that you draw in a volume of fluid. And just one great, right, and the most classic one that we have is the force of gravity acting on every single element of fluid. And right, and then it doesn't really matter what your coordinate system that you set up is, right? You always can just take this, right, the force of gravity, right, is the, right, we go mass, a little bit of mass times the gravity vector. So, right, one body, right, so then one body force we always get is, right, component-wise, in the x direction, got this little bit of mass, and then in the x direction, which is just taking this vector that lives in space and projecting it onto, let's say, the x, the y, and the z. So this is just, so body forces are strange just because body forces exist in the world and its gravity is always pushing something down, let's say the surface of the Earth right here. And they're independent of whatever coordinate system you want to draw out. So that's why you have these projection components, right? This is always just going to point downward, and that's what vector equations are getting at. It doesn't matter what coordinate system you draw out, I can break it up into the components of the coordinate system. So, right, this body force of gravity sometimes is even lumped into the pressure term, just because you can do a vector operation and do a vector operation and make it look like a pressure term. But we don't really have to do that, and some people just like to keep it on its own, right? So this is also the y component, and then this one body force. So this is a component, and this is a vector expression. But there are other ones you could have as well for body forces acting on a fluid, right? Gravity is one that's caused by the Earth's surface creating some field that's pulling everything down. So it doesn't matter what point I draw, they'll all still be drawn towards the surface of the Earth. But you also could put this liquid in a magnetic field as well. And since the magnetic field acts on every single point as well, you could maybe you could have a body force that actually would be pulling the fluid, maybe let's say some this way. So that would be another body force acting on it. And it would come from some law. So you could have a body force of gravity, a body force magnetically, and I don't think I can think of actually acoustic. I think acoustic. No, I don't know other body forces, but you can look them up, and they really are not the most. Gravity always is our most important body force because at least on Earth it's always here. For instance, I research low gravity fluid mechanics, so for stuff in space where we don't actually have the force of gravity to affect the fluid. So it's not always there actually, but just because it's a body force and we live on Earth, it always earned its own term in that Navier-Stokes equation with the gravity. And in your book as well, you'll see that the gravity term comes around. So I will write these ones out in full for you, just because everyone should see them at least once. See how many terms there are for just one of these. That's the problem, right? So this is just one, and then you have there's a similar one for the y momentum and a similar one. But the z momentum. And this is still in terms of the Cauchy stress terms, which are the 9 components. And then we also, don't remember, you also had incontinuity, and that's for an incompressible fluid. I'll do the component-wise as well. For an incompressible fluid, is that. So this is continuity. Extra credit, do the other 2 as well. Write them out in full notation. Okay, one more